happy to be here on the last session. So I hope that you are not sleeping yet. All right, so let me just start my presentation. And yep, I hope you see the screen, and we can start our discussions about the observability, right? What observability is, how to play with that, and what we need to do in order to have this observability really in our organization. Also, on the end, or maybe in the middle, we will look how this observability implementation may look in case of serverless, of Lambda functions in AWS. So let's get started then. But first, we need to ask ourselves, how good is our monitoring? Please answer to yourself. Are you happy with your monitoring right now? Or maybe not, right? And honestly speaking, I personally am never happy with my approach to monitoring, right? There is always something to improve, always something to change, always something to do better, right? Okay, so my name is Piwosz, and I am DevOps Institute Ambassador, AWS Community Builder. So that's why we'll talk about AWS Lambda and CD Foundation Ambassador. I started to be interested in this topic about the observability even before the buzzword observability came into the picture. So I have even my own private thoughts about this area. Right, so why we talk about this at all, right? From where it came. The problem is that today, with this all nice stuff like clouds, like platform as a service, software as a service, etc., 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 we have less and less visibility. What it means? It means that when we had the bare metal, and I'm old enough to work with bare metal for a long time, we saw everything. We were able even to monitor the, the flow of the power to the systems, right? Then we start to talk about virtual machines, right? And in this point, if we weren't in this place, in these teams, which have the ownership of the platform, we are responsible only on the about the virtual machines on this platform. We lost some of the visibility, but still we have the full picture of the behavior of the machine itself, virtual machine itself. But in this case, sometimes we observe some problems in our virtual machine, which are not connected to our virtual machine, or which not are triggered by our virtual machine. So for example, if you are interested in this topic, please take a look what the steal time means when you do the top command in the Linux machine, right? This is strictly connected to connection between virtual machine and hypervisor. Then we came to the containers, and we lost even more visibility, right? Because container is, again, somehow encapsulated part of our systems, lower, maybe smaller part of our system, where in fact, let me say this in that way. If we logged into container to see what's going on, we do something wrong, okay? And then today we have serverless, right? And of course, serverless means that there is a server, but we don't see the server at all. But we do not have almost any knowledge what's going on there. And why this happens? Why this visibility is lower and lower? Because we have less interactions with the systems, right? We have less accessibility to the system. You cannot log into the serverless machine and see how it works, right? You have much more tools than we had before. We don't like central logging anymore. And because of the nature of the, let's say, modern design of the applications, of the systems, right? With this decoupling, microservices, serverless, which we can even say that the serverless is kind of nano services, right? And this less visibility is here already. So we have different cloud computing models, starting from the on-premise, because we can have cloud computing on-premise as well. We can have infrastructure as a service, platform as a service, and software as a service. Sometimes we even say the function as a service with the case of serverless. And here in the green, you have those elements which you manage, which we manage, right? When we play with this. And those red are those elements which we are not touching. We don't know what's going on there, right? And there is more and more and more with every single model, or there's more of elements which we are not controlling. And this may be a problem, right? So because we cannot catch logs as we used to do so, we need to find the new approach to this, more complex, more responsive way of collecting this information to really understand what our application does, right? And there is another layer of it, because when we have the monolith, we don't necessarily need to control and monitor the data flow between the elements, because monolith is a monolith, right? If we have microservices, we have also the traffic flow, data flow between those microservices, and this is also important. So first element which we need to discuss here in order to go into the better understanding of our application and even start thinking about observability, because this is the first part which I want you to somehow understand, because this is a problem still to understand what observability is the structured log, right? So let me say that without structured logs, we cannot have the observability, okay? And what is structured log? So by definition, done by Samologic, the structured logging is the practice of implementing a consistent predetermined message format for application logs that allow them to be treated as data sets rather than text, right? In other words, structured log gives the information to the automated system, not necessarily to human, what's going on and what is the surrounding, right? So this is not only the message error for success. This is also related to the statistics, to the behavior of the system, application, component, etc., etc., etc. This is everything here, right? This description here, what you see on the screen, really describe only part of it. There's something what we can call structured message, right? And this is very important, but still this is not the structured log. Why structured message is important? Because imagine that your system is sending 100,000 log lines per second, and you have a couple of that systems. And then you have some shipper and some logic which need to comprehend this number of messages. What will be easier to this system? To understand and react to exactly the same structure, or have multiple structures from your different logs, understand the structure, apply the transformation, and then understand it? The answer is, I believe, obvious, right? So again, from Sumo this is like a standard log line from the system, right? It's quite informative. It's quite okay if you have one machine. If you have 10,000 machines, not necessarily, right? We can improve this by creating from it kind of structured message, right? But this is still not helping in the situation that we have like 10,000 machines, but we can play with this kind of line easier. It's kind of JSON, it is editable, it is easy to understand for the machine. Good stuff, right? And then we have structurized log line, right? And here we, as you can see, we have a little bit more information, right? So here, this is just the bare information about the thing, nothing more. Here we have more information, like for example, what is the value of the action, right? So we are able to understand more, and we are able to build some measurements based on it. So this is the good start, but we do not have structured log yet. And here we are coming into the observability topic. So first of all, please do not claim that you have observability because you have Grafana on Kubernetes. If you have Grafana on Kubernetes, that's great. Those are great tools. But the only thing you have at this point is Grafana on Kubernetes, nothing more. Okay? Observability is a process, is a framework which contains of 3 elements. It is logs, easy stuff, traces, not easy stuff, and well, so easy stuff, metrics, right? About logs. So we always, maybe let me not be that harsh. We very often claim that we write everything to logs, right? But in fact, we have a problem because we have here a small but. We write errors only, right? Because errors are important. And we write those errors only because we must save money. Great. What can go wrong with that, right? How you will understand that your system is really broken, or just a little broken, or maybe one component is not working well, or whatever, right? You don't have any information, any context here, right? So with this, we need to have the continuous information about the performance of our system. Maybe not performance, behavior of our system, right? So everything should be logged. Another element is metrics in scope of observability. And by metrics, we do not think just simply about the numbers, right? Metrics can be calculated based on some thresholds, on some time spans, etc., and how system behaves normally, how system behaves in the span of 1 hour, 1 day, 1 week, 1 year, right? So these are the kind of easy to show measurements of the performance of our system, right? And very often, and this is really very often what happens, that what we have, for example, information that, okay, we had like 10,000 requests to our Nginx servers, and only 2% of them were errors. Nice, that's a good start, right? But now we can have measurements. What caused those errors? We can have measurements, how the system behave during the normal time, because probably something happened during this normal behavior which led to errors, right? So very often when we ask about metrics, we hear that they are great, but really we don't know how bad they are because we are not collecting them, right? Or not collecting them in the long enough time span to really understand the behavior of the system, right? we can collect measurements or metrics from the logs, but this is very, very, very long process, right? We need to really apply a lot of effort to have it, right? But still, if someone from business will call us and say, hey, we have this very important client who is paying us like, I don't know, bucks of dollars per hour, and I need to know right now what he did 5 minutes ago, because he called me and complained that he has an error. You will be not able to collect this information from logs and from metrics because you don't have traces, right? And with traces, you are able to, let's call it this way, spy the request from the start to the end and back, right? So from the client to database, let's say this way, and back to the client. That's why trace is allowing you to watch the whole way of the request through the whole system, right? And find the bottlenecks, find the potential problems. And in all of those three, the context is the most important element, because without context, you are blind. What is that? Please think about this. What this can be. And now, please be kind of, honest with you. Who thought that this is the planet? Right? Here it's simple. Right now, that's obvious, right? But with that, not necessarily, right? So without context, you should feel that you lost something, you missed something, and you really miss it, right? Now, what is the context in the observability? We had these three elements, right? Logs, metrics, traces. So logs helps us to understand the surrounding, right? Logs gives us this awareness what's going on around. Paths, not paths, but traces gives us an understanding of the path, right? How it came to this situation. And the metrics helps us to understand the scale of the issue, right? And now we will talk about the tech stack. This will be the presentation for live demo. And I don't know how many of you are familiar with AWS and specifically in AWS Lambda, but I will go through the service with you, and then I will show you what we can have if we implement the observability there. So with standard template done in CloudFormation, in fact, it's SAM. So the SAM is a AWS framework for serverless application model, where you can implement as code kind of GitOps-ish approach to infrastructure as code, right? And this is our starting template. I don't want to go through all of this. This is, of course, the YAML, because all DevOps are the YAML programmers, right? And what we have here, the most important element. So this resource here is our Lambda function, right? And on the end, I will start on the end because why not? We have the event, and this event declares that also the API should be created for this serverless, and this function should be connected to the endpoint / with method get, right? Simple like that. And here we have some information like what is the handler. This is the case for serverless, that we always have this handler. This is the main place where what executes the code when function is called. We have information where the code is. We have the information about runtime and some other stuff, right? And with Lambda, we have some limitations, right? The limitation related to the throttling. The limitation related to the how many concurrent, this is also related to throttling, how many concurrent execution we can have. The limitation related to the space used by our function, or the time in which our function should finish. And the most problematic is something what is called cold start, and I will show you this cold start in a minute. So generally, cold start is the moment when you try to hit Lambda, which is not warmed up, right? So there is no infrastructure prepared by your vendor. Your code is like a cold. You need to just take it from the fridge and warmed up to do something, right? And here we have only 20 lines. That's all. And this will create our API gateway. It looks like this in the console. And our Lambda function, it looks like this in the console. Nothing fancy, nothing interesting. And when we execute this, we have some metrics. Very informative, right? We have the full one dot. Perfect, right? Okay, maybe we can have something more. Yes, we can. We can have the measurements for the how many invocation we had in time, how long our Lambda function took to be executed, the duration, how many errors, or what is the rate or ratio between errors and success, and few more, like 9 or 10 measurements, right? So it's not much, right? We have logs, of course, right? And this here, this three open, or let's say lines or records, this is the whole log which by default Lambda function in Python writes in the CloudWatch. Again, a lot of information, right? Of course, I can put print or whatever else to the code and just send something to the output, but this will be not structurized. It will be chaotic. It will be problematic, and please don't do that. Okay. The only useful information here is that what is the duration of the function and how much I will pay for it, and how much memory was used, etc., etc. Right? And that's all. So what we can do with that? We can easily improve this on the level which I call the exterior. Okay, so we need to enable something what is called X-ray. And this X-ray is not the X-ray from the testing, from the QA world. This is the X-ray service delivered by AWS, which allows us to go with the request, with the trace of this request, okay, from the start to the end, if possible. So we need to enable it. By this, we need to go to our Lambda function, go to the configuration, like here, the setup, then to monitoring and operation, and then we need to click edit, move this slider here, and we become senior. If we want to go into the leader position, we can enable X-ray even on API gateway. So again, we go to the API gateway, go to the, we select the tab log tracing, and we enable X-ray tracing. That complicated it is. Okay. And we will have on the end something like that. And now we can see a little bit more things, right? So here, what we have? We have information that the client connected to the Lambda function, executed the Lambda function, and this Lambda function has some code there, right? Or another client went through the API gateway, which executed the Lambda function. We have the timing, we have the ratios, etc., etc. We have this information in better way. If we have even the response distribution time, perfect. But this is still not everything. We can now go to traces, right? And you can see here the list of traces. So every single trace is the execution of the API, and you can see here the response times. And we have the longer one, 28 milliseconds, and the slowest 16 milliseconds. This 9 millisecond is the execution which I know was executed without API. It was execution directly through the Lambda. How I know that? Because there is no get, right? No method at all. So this was executed through the Lambda function directly. So we don't care about this. So we have 16 milliseconds to 28 milliseconds. You can say that's not much, right? But it's almost twice. So what happened here? Let's take a look. This is the trace for 28 millisecond long request. And please observe here, we have some space, right, between those two blue lines, and there is nothing there. So if you know what is there, you know this is the cold start. I know, but no, not all people need to know, right? And now let's take a look on the 16 millisecond long run, and you see this part here is shorter, right? If we see that again, it's different, right? Why? We don't know it here. We don't have a clear information what happened. So we need to enable one more thing. This is called Lambda Insights. By going into Lambda configuration, monitoring, etc., like we did before, we enable this enhanced monitoring, and after that we have this information. And here is we have very interesting column. This is called init duration. And if something is here, it means that we have cold start. But what is in this cold start? This is another question, right? So what we can do more, we can enable logging and tracing in better form in the API. So the same place like we were before for API, we need to enable CloudWatch logs, request response data. Please remember that log full request response data is not necessarily a smart choice if we talk about production, because this will log the whole request. And we need to enable detailed CloudWatch metric. And this will give us the possibility to set up the access logging. And I strongly recommend to provide your own. This complicated stuff I did just by clicking this insert example JSON. Because I am lead, I know what to click. And I added from myself only this trace ID. So here I'm collecting the trace ID of the request, which will go through the whole life cycle, through the whole system. Why this is important? Because by default, API doesn't log anything. We need to enable it. And please remember that this X-ray tracing still is there, right? And we will have something like that after that. So we will have the information about the call itself. Not very detailed, but enough to start. Okay. With this logging, we can also monitor, for example, how many IPs and how often people logged or do something on our API. Just like that, a couple of clicks and we have it, right? But those was about the externals. Now we need to talk about internals, because we still don't know what's going on in the code, right? So for this, we will use the AWS Lambda Power tool. This is the open source software from AWS. It's not the open telemetry, or I should say a little bit different. It is quite similar to OpenTelemetry, but for the OpenTelemetry itself, AWS has different library, but this is quite powerful. And we have multiple ways of implementation. We have power tools ready for Python, TypeScript, Java, and recently for .NET. This allows us to build the observability really out of the box, right? And the best use of it, especially for Python, is to have this as a separate layer, because we don't need to care about the power tools code at all, right? So this is like import something from, from the internet. And finally, we can start to implement it. And after we implement it, we have definitely better information, right? Much deeper information. We can see even behavior of the particular part of the code of our function, right? We can see much rich logs, okay? And the full template is like this. I know this is very small letters. You will see this in the second. So we have much more, right? And this is 67 line. Of course, the Python code needs to be changed as well, but believe me, it's not much. So if you want to implement this by yourself, this is the article when I do this step by step. But now what we will do, we will look on it in the real environment. But I need to log into my AWS. Give me a second. I'm just almost there. Right. So AWS console, we go to the, let's start with API first to show you where I enable this stuff. So we have our API here, right? Very simple thing. We have our methods here, but if we want to enable this tracing, etc., we need to go to stage. We need to go to our stage where we want to enable it. We have logs and tracing, and we click the stuff here, right? So here is this log configuration I showed you before. So this is for API. Of course, you need to change this for every stage you have, because this is the stage related, and then you need to I'm sorry, deploy the API again, right? But it's not the big deal. So this is the API. Then we have Lambda. And in this case, we will go through the, I think this is this one. Yes, this is this one. We have our Lambda function here. What is nice with this SAM model as well, that you saw that everything was grouped in one application. That's nice, right? And we need to configure our Lambda. So we go to the configuration. We go then to the monitoring and operation tools. And as you can see, I have log and metrics enable, active tracing enable, enhanced monitoring enable, right? So in order to change this, I have the button edit, and then I can enable everything. What is nice about this Code Guru profiler, this is the machine learning power tool from AWS, which gives you the insights into your performance of your functionality. And then save, and you have everything here enabled. But in fact, let's go first into the code. So we see the code first. I think it will be this one. Yeah. So here we have our template, right? And this template here is, as you can see, quite simple. What we have more than we had on the beginning, we have a resource for the logs in CloudWatch. This is for API. We have the layer with power tools, right? And we have the definition of API. So this is like I extracted from what was done before, and we create the API and then connect this API to our Lambda function, or we connect our Lambda function to this API. We need to have some additional policies, and here we have the layers attached. So we have the power tools and we have Lambda insights, right? And honestly, that's it in this code. So no magic here, right? And then we have, I was very intelligently went off. Then we have our Lambda function, and this Lambda function, believe me, is very simple. Please don't laugh on me. This is only for the demonstration. What I've done here, I have handler and couple of functions, separate functions, to just give the impression what is possible to be done, right? So going on the bottom, this is our handler, right? This thing here. And in order to instrument our Lambda with power tools, I need only these 3 lines. Done. I don't need anything else, honestly, right? So here I have the decorator for metrics. I additionally said that please capture call start metrics for me. I have the decorator for traces, and I have decorator for logs, right? And here I said, please log the whole events for me. Please don't do that on the production, and please create the correlation ID, which will go through whole chain of events, right? And then I can instrument it with things like that. So I'm adding another metric, right? Here I have this separate functions, right, in my code. And for this, what I need to do this is only the trace. So if I want to trace all particular elements of my code, I need to decorate it with the trace. I don't need to do this for metrics and logs. It will be captured anyway. So here I have the even the annotation for the traces, so I can give, or I can have more information, more deeper information, right? I can build, as you can see here, I'm building the excuse me, customized metric here to have it, right? So a lot of stuff was added here, and what I need to do is this 3 imports to be able to do that, right? And what is cold start? Here we can see the second type of cold start, because first type of cold start is the time needed for AWS to provision all resources, and the second type of cold start is what you do during the initialization of your functionality. And everything what is here from the 0 or the line number 1 to the first function, let's say. So everything what is outside the functions, especially the function handler, right, which executes those functions here, will be executed during the cold start, during the first initialization of the function. Later, it will be reused because this function will be powered up and warmed up and ready to deliver your stuff. So what we can check to see that is, I will go again to API. I will just, no, I don't need to. So I will go to the Lambda, I'm sorry. Then I will go into Lambda demo, yes. I will go to my function and to monitoring. So here we can monitor everything we run. But what I will do, no, I can stay here. I will execute a couple of times something very simple. Let me try to make it bigger. I cannot. I will just send the CURL to my function. And you please observe, it took some moment, right? What will happen if I execute this once again? It was immediate answer, because first function need time to provision. second execution didn't need that, right? So if I do this couple of times, I should have some logs here. Let me just refresh it. Maybe we will see it already, or maybe not. AWS needs some time to show logs, unfortunately. Maybe we can jump to CloudWatch logs and we can see this there. Yep, we have more information here, as you can see. So this is our last executions here, and you can see that there is much more information, right? And I mean it, much more information than it was before. And what is interesting here, if I go to the first one, and for example, I will just open that, I can probably find the information about cold start, because this is the information which interests me the most. Yeah, so here we have cold start true, right? And if I close this record, this is everything for the one execution. First execution ends here, and here starts the second one, right? Let's check the same information, cold start false. So this function didn't suffer from cold start. Looks cool, yeah? So let's just check something more, maybe traces. So this is quite simple. Let's go to X-ray. Maybe in X-ray we will see a little bit more, and we have 4 minutes left, so I will finish in a second. So we have our response time distribution, we have our traces, we can see the response time, we can even order it by the response time, and you see the first one was more than 1 second. Second already has the 10 milliseconds, right? So let me just check it. So here we have the trace. We can see this trace, right? We have the full information. We have this initialization time, right? And in the second one, this initialization time was very short, right? There is almost no initialization time. There was non-initialization time. So this concludes the demo. I hope it was useful for you. And yeah, if you want to play with this, please go into this link, and I hope this article will be kind of helpful for you. The last thing which I want you to remember, who is your monitoring server? This is the quote from DevOps Borat, who is unfortunately not with us anymore. So thank you very much. If you would like to stay in contact, please feel free. These are the links to my profiles. And yeah, thank you very much for your attention, and have a good day.